Welcome, my friends! Today we will be discussing a very important factoring technique called completing the square. Consider x squared plus 10x. Completing the square will work whenever you have one variable squared and the same variable also to the first power, either subtracted or added. The x squared term should not have a coefficient. If it does, you'll have to factor it out, as I'll show you in a later example. Our problem has both an x squared and an x term, so we can complete the square. What do we do next? Well, the point of completing the square is to force your problem to factor as a perfect square. In other words, we want this to factor as x plus k squared, where k is some constant. So how do we do it? Well, look at the coefficient on x. In this case, we have 10. Take half of this coefficient and square it. Half of 10 is 5. 5 squared is 25. This tells us we need to add 25 to our expression, and then it will factor as a perfect square. Let me show you. Adding 25 to our expression, we have x squared plus 10x plus 25. Of course, in most cases, you'll be working with an equation, so you'll have to also add 25 or whatever value to the other side of the equation. We'll look at an example like that later, but just accept now that we have changed the expression by adding 25 in this problem. Okay, so now we need to factor this thing. We are looking for two numbers that add to the b term of 10 and multiply to the c term of 25. If you've done everything right, the two numbers should be the same, and they should also be half of whatever the b term is. In this case, we have 5, as 5 plus 5 is equal to 10, and 5 times 5 is equal to 25. This means this factors to x plus 5 times x plus 5, which is the same thing as x plus 5 squared. We have forced our expression to factor as a perfect square, which required us to add 25. This will always work and is a really nice factoring tool. All you need to remember is to take half of the coefficient on x and square it. That's the number that needs to be added to the expression to make it factor as a perfect square. Whatever half the constant on b is, will be the constant in the perfect square. Let's look at an equation that can be solved by completing the square. Let's say we have x squared minus 16x plus 53 is equal to 0. You could try to factor this like normal, but there are no nice numbers that add to negative 16 and multiply to 53. You could use the quadratic formula to solve this, but completing the square will also work. Take half of negative 16 and square it. Half of negative 16 is negative 8. Negative 8 squared is 64. So we add 64 to both sides of the equation to get x squared minus 16x plus 64 plus 53 is equal to 64. Now, you purposefully do not want to combine the constant you added with any other constants, so I will not add 64 and 53 together. Instead, we will move the 53 to the other side of the equation by subtracting it from both sides. We are left with x squared minus 16x plus 64 is equal to 64 minus 53, which is 11. Okay, the left-hand side should factor as a perfect square if we've done this right, with the constant being half of the coefficient on x, which is half of negative 16, or negative 8. So this should factor as x minus 8 squared, which is all equal to 11. If you want to check to make sure, you can FOIL out x minus 8 squared. You should get x squared minus 8x minus another 8x plus 64, which is just what we had before, x squared minus 16x plus 64. Now, we can solve this by taking the square root of both sides to get x minus 8 is equal to plus or minus the square root of 11. Adding 8 to both sides, we get x is equal to 8 plus or minus the square root of 11, meaning our two answers are x equals 8 plus the square root of 11 and x equals 8 minus the square root of 11. I mentioned earlier that if you have a coefficient on x squared that is greater than 1, that you should factor it out. So let's look at a problem like that. Let's say you have negative 3x squared plus 12x minus 7 is equal to 0. Let's start by just getting rid of the negative 7 by moving it to the other side. We have negative 3x squared plus 12x is equal to 7. Now we need to complete the square with the left-hand side. Since the coefficient on x squared is not 1, we will start by factoring out a negative 3. Factoring, we have negative 3 times x squared minus 4x, all in parentheses, is equal to 7. The easiest thing to do next is to divide both sides by negative 3, so that we have x squared minus 4x is equal to negative 7 over 3. Let's add half of the coefficient on the x term squared to both sides. Half of negative 4 is negative 2. Negative 2 squared is positive 4, so we must add positive 4 to both sides. We have x squared minus 4x plus 4 is equal to negative 7 over 3 plus 4. 4 can be rewritten as 12 over 3, so we have negative 7 thirds plus 12 thirds on the right-hand side. This is the same thing as 5 thirds on the right-hand side. The left-hand side factors as a perfect square, with the constant being half of the b term of negative 4, which is negative 2. We have x minus 2 squared is equal to 5 over 3. Taking the square root of both sides, we have x minus 2 is equal to plus or minus the square root of 5 over 3. Adding 2 to both sides, we have x is equal to 2 plus or minus the square root of 5 over 3, which means that x is equal to 2 plus the square root of 5 over 3, or x is equal to 2 minus the square root of 5 over 3. Alright my friends, that wraps up our video covering completing the square.